Welcome to Mrs. Miller's notes for her pre-calculus class. These are the notes for section 3.4 entitled Real Zeros of Polynomials. And today we're going to talk about rational zeros of polynomials. So we're going to talk about finding all those rational numbers that are solutions to a polynomial or a polynomial equation or function. And then we're going to use our calculators to help us solve polynomial equations as well, because there's a feature in your calculator where you can find the zeros of a function. Okay, now we've talked about the factor theorem in the past, and it tells us that finding the zeros of a polynomial is really the same thing as factoring it into linear factors. So when you factor a big expression, or equation or function, then that is going to help you find all of your solutions, all of your x-intercepts, and all of your zeros. So it's all connected. So in this section, we're going to study some of the algebraic methods that we can use to find the zeros. Okay, so we're going to start with the rational zeros of polynomials. And if you take a look at this polynomial that they have listed here, they have p of x equals x minus 2 times x minus 3 times x plus 4. And that's the factored form of it. And then they also have the expanded form where they've gone through and they've multiplied everything out. So you have x to the third minus x squared minus 14x plus 24. Now from the factored form, we can see that the zeros are going to be x equals 2, x equals 3, and x equals negative 4. So those three little sets of parentheses would be what we would set equal to 0 and solve to get our x-intercepts or our solutions or our zeros. And if you take those three numbers, the negative 2 and the negative 3 and the positive 4, and multiply them together, you get 6 times 4, which is 24. And that's the constant term that's added on at the end in the expanded form. So there's a connection between these two concepts, the factored form and then that constant that's being added on at the end. And what that means is that the zeros of the polynomial are all factors of the constant term. So if you take the factors of your constant term and list them all out, your answers have to be in that list somewhere. So that's a pretty cool thing to know. And that is actually what we're going to use when we're dealing with the rational zeros theorem. To find all of the possible zeros, we're going to basically do our P's and Q's here, is what I like to call it. We're going to take all of the factors of the constant term, which are going to be which is what P represents. And we're going to divide them all by the factors of the leading coefficient, which is what the Q represents. So it's basically your constant factors over the leading coefficient factors. And that gives you a list of all of the possible zeros for a polynomial. And then we want to use that list and synthetic division to help us narrow down our selection and find the actual zeros for a polynomial function. So let's take a look at this example here. And we're not actually going to do the synthetic division with this one, because this one I just want it to be a little bit more conceptual. Okay, so to find the rational zeros of p of x equals x to the third minus 3x plus 2. Okay, so my leading coefficient is going to be a 1, and my constant is going to be the 2. So those are the two numbers that I'm going to put together in that p divided by q thing. Actually, I probably should have written them in reverse order, because that's the order that we're going to actually use them. Okay, so we'll have our constant term is 2, and then our leading coefficient is 1. Okay, so that's the order that I'm going to divide them in. So it's kind of like the last term and then the first term. Okay, so my P over Q would be plus or minus 2 over plus or minus 1. Now I want to consider all the positives and all the negatives, so that's why we put that plus or minus in there. Because you could have a negative divided by a negative that gets you a positive value, as well as a positive divided by a positive that gets you that positive value. Okay, so then what we have to do is we have to list out all the factors of 2 and all the factors of 1. So all the factors of 2 we have to divide by all the factors of 1. Well, the factors of 2 are 1 and 1. I'm sorry, 1 and 2. So we would have 1 over 1 and 2 over 1. And again, we want the positives and the negatives in there. Okay, now that's it. These are all my possible combinations of factors. So I could have positive 1, negative 1, positive 2, negative 2. Those are my 4 possibilities for my solutions. Okay, and notice that they're all factors of that constant term. They're all factors of 2. Now when we actually go through these problems, like in example 2, we're going to use synthetic division because we're going to have a much bigger list of all the possible factors that we could have. Okay, but we only have 4 here. So let's just real quick do some substitution here and see which ones work. If I do p of 1, then I'll have 1 to the third minus 3 times 1 plus 2. So that's going to be 1 minus 3 plus 2. That's going to be 0. So remember, if you substitute a number into a function and you get 0, that means you have no remainder. So that means 1 is a factor. So that would be one of my rational zeros. Let's try negative 1, see if that works. Now, I already have 1 as a factor. I know I need the factors of 1 and 2. So hopefully you can deduce here that negative 1 is not going to work. But if not, we can test it and we can prove that it's not going to work. So negative 1 cubed is negative 1. Negative 3 times negative 1 is 3 plus 2. That's going to give me a total of 4. So no, that doesn't work. Okay, that means I would have a remainder of 4 when I did the synthetic division. So let's try p of 2. So I'm going to have 2 to the third minus 3 times 2 plus 2. So that's going to be 8 minus 6 plus 2. And that's going to get me a total of 4 again. So that's not going to work because I want my total to be 0. I don't want to have any remainders. So let's try p of negative 2. This is probably going to be the one that's going to work. So negative 2 to the third minus 3 times negative 2 plus 2. That's going to be a negative 8 plus 6 plus 2. There we go. There's my 0. Okay, so then my rational zeros, or rational zeros, I guess I should label it, are going to be 1 and negative 2. So those, if I were to factor, those would be my solutions. Okay. Now, how we're going to do this, oh, that was just extra room in case I needed it. Okay. Now, how we're going to do this, though, when we're dealing with much more complex polynomials with a lot more factors, is listed here in this little box. Okay. We're going to list all the possible zeros like we just did, and then we're going to actually do synthetic division to narrow down our selection. And then once we find one that works, we'll have what's called a depressed polynomial, and that will hopefully be factorable. If not, then we're going to repeat this process where we would list out all the possible zeros, use synthetic division to find one that is an actual rational zero of our polynomial, and then we'll get another depressed polynomial that we can divide. And if we need to repeat this process 3, 4, 8 times, we will. Most of the time, you just have to do it once, though. Okay, so for example 2 now. Let's take a look at this polynomial. We have 2x to the third plus x squared minus 13x plus 6, and we want to find all of the zeros. So to find all of the zeros, first we have to find all the possible zeros. So again, that's where I take a look at my constant term, which is 6, and then my lead coefficient, which is a 2. So that's going to be my p over a q. So I'm going to have plus or minus 6 over plus or minus 2. Okay, and now to get my list, I need all the factors of 6 over all the factors of 2. So I'm going to have, let's see, the factors of 6 would be 1, and the first factor of 2 would be 1. So I'll have 1 over 1, and then I would have 2 over 1, and 3 over 1, and then I would have 6 over 1. So those are all my factors of 6, 1, 2, 3, and 6, over my first factor of 2. My factors of 2 are 1 and 2. Okay, so I just put all the factors of 6 over 1. Now I'm going to go through and I'm going to put all the factors of 6 over 2. So I would have 1 over 2, and then I would have 2 over 2, but that's going to reduce down to 1 over 1, which I already have. Then I would have 3 over 2, and then I would have 6 over 2, but that reduces down to 3. So there's my list of all my possible rational zeros. And all of them are plus or minus. If you want to put the plus or minus in front of all of them, you can. Sometimes that makes everything look kind of messy and kind of smushed. So if you just want to put one plus or minus out in front of your whole list, that's fine too. Okay, and I can get rid of that little comma there because we finished our list. Okay, so now I'm going to go through this list and I'm going to start to find, or try to find, a polynomial that will divide and give me a remainder of 0. I want to find one of these numbers in this list that will divide evenly into my given polynomial function. So I say start with 1, then go to 2, then go to 3. If none of those work, then go back and do -1 and -2 and -3. Usually in the first few terms, you're going to find one that works. We're not going to give you a real crazy polynomial that's real time consuming where you have to try 5 or 8 different numbers before you find one that divides. Okay. You might get some fractions as well that could be solutions. Those are kind of irritating to have to do polynomial, or I'm sorry, synthetic division with a fraction. It can be done, but it's just a little more irritating because you got to work through with fractions. So try the whole numbers, try the positive numbers first. Okay. Just to save time in our notes here, I'm going to tell you that 2 will work. And we're going to set up our synthetic division. Just like in the previous notes, when I do synthetic division, I want to make sure I have every term accounted for. And I do here. I have a 3, 2, and then an x to the first. So I have 3, 2, 1, and then I have my constant. So I'm going to have 2, 1, -13, and 6. So I don't need any placeholders because I have every term accounted for. Remember, we add down the columns, and then we multiply by the number in the box. Add, and then I multiply. And I multiply, and then I add. Okay, so remember this last term here, putting like a little fancy squiggle line to separate it. This last term, that's my remainder. Okay, now I want my remainder to be 0. In order for this number in the box to be a solution, to be a rational 0, I have to get a remainder of 0. If I don't get a remainder of 0, then that means that that number that I picked and put in the little box is not going to be a solution. It's not going to be a rational 0. Okay, so x minus 2 will be one of my rational zeros. So 2 is a 0. Okay, and then I have these terms here. These are the coefficients for my depressed polynomial. It's depressed is the name that they use for it because it's shrunken a little bit. It's lost a power, so it's lost a degree, and it has one less term than the original polynomial. Okay, So remember, we started with x to the third, so now this is going to start with x squared and then go to x and then my constant term. Okay, so now this polynomial, this is my depressed polynomial, this is what I want to try to factor. Now, if you can factor with guess and check, do that. You might see difference of two squares, you might be able to do grouping. Worst case scenario, you'd have to do quadratic formula. Okay, but this polynomial I can actually factor, so I'll come up here and I'll factor it with guess and check. I need the factors of 2, so that's going to be 2x and x. And then I need the factors of 3. Now here we have to kind of guess where the 3 and the 1 are going to go. So if I try 1 and 3, remember when I check my outers, I'll get 6, and my inners, I'll get me a 1. I want them to add up to that middle term of the 5. And I can get a 6 and a 1 to add up to 5 if I make the 6 positive and the 1 negative. Okay, so we were able to factor that with our guess and check method. So now, if I took 2x minus 1 times x plus 3 times x minus 2, now this minus 2 is coming from here, that is the group of binomials that I would have to multiply together to get this original polynomial back. Okay? And if I wanted to find my zeros then, I would set each of these equal to 0 and solve them. So I would get 1/2 and -3 and 2. And again, that 2 is the same as the 2 from this box. It's the 2 from the list. Notice that -3 is also in the list, and 1/2 is also in this list. Okay? And if you multiplied 3 times 2 times 1/2, 3 times 2 times 1/2, you get 6. Okay? So it's very cool how all of this is connected. Okay, and that was just more room if we needed it, which we didn't. Okay, now example 3. This one is going to have an extra step to it. So again, it says to factor the polynomial and find all of its zeros. So we're going to start off by listing all the possibles. So my constant term is the 10. My lead coefficient is 1. So that's going to be my p over q. So that'll be 10 over 1, plus or minus. So basically I need all the factors of 10. Okay? So I need 1 and 2 and 5 and 10. And you could put these all over 1 if you wanted to, but the only factor of 1 is a 1. Okay? And again, all of them are positive and negative, even though I just have this one positive negative out front of the whole list, all of them are positive and negative. Okay? So those are the terms that I have to choose from in order to find my actual rational zeros. Okay? Now remember, there are factors of this number at the end. Okay? So if 1 works, then a 10 is probably going to work because 1 times 10 is 10. If 2 works, then 5 will work because 2 times 5 is 10. So that can kind of be a clue as well. Okay? So now I'm going to start my synthetic division process. And I'm going to try and find one of the polynomials, or one of the numbers here from our list that will divide evenly into the polynomial. And remember, for synthetic division, when we want something to divide evenly, it's got to have a remainder of 0. Okay? And again, start with the positive numbers. Start with 1 and 2, and then 5. If none of those work, then go back and do the negatives. Do -1, -2, -5. Okay? Just to save time again, I'm going to tell you that 5 will work. And if I look at my polynomial here, I've got 4, 3, 2, 1, and then 0. So I have all terms accounted for. I have them all in descending order. So when I set up my synthetic division, I'll have 1, -5, -5, 23, and 10. So remember, those are the constant terms, or the coefficients in front of each term. And then I put a 0 there for the placeholder, and then I add down the column, and then I multiply by what's in the box. Okay, so that's going to be a 0. That's a 0. That'll be a negative 5. So that's a negative 25. So that's a negative 2 times 5 is going to be negative 10. And there, my last term is my remainder. I got a remainder of 0, which is good. Okay, so that means 5 is going to be one of my solutions. It's one of my zeros. And then I have this depressed polynomial that I'm going to write. These are going to be the coefficients of my depressed polynomial. It's depressed because it's 1 degree less. So I'm going to start with 1x to the third. I'm going to write the 0x squared in there just for now. And minus 5x minus 2. Okay, so I have 4 terms basically. And if I was going to try to factor this, I would have to factor by grouping. But there's actually no way that I could factor that by grouping. So when this happens, you don't just stop and say, oh, that's my answer. You want to keep going. So remember when we looked at that chart in the previous slides, it had the third step was repeat. This is where you repeat. Okay, so I need to list then all the factors of, or all the possible zeros of this new depressed polynomial. And I think I have an extra slide here to show work. Yeah. So let me rewrite this. I have x to the third plus a 0x squared minus 5x minus 2. So my constant term is the 2. My leading coefficient is the 1. So I basically need all the factors, all the factors of 2 over 1. So that's going to be plus or minus 1 and plus or minus 2. Okay. And again, we would try to choose from these 4 numbers, positive 1, negative 1, positive 2, negative 2, to see if I could synthetically divide it into my new depressed polynomial. I'm not working with the original anymore. Okay? And again, to save time, I'm going to tell you that negative 2 will work. Now here when I set up my synthetic division, I need that 0 for a placeholder. So it's good to have that written in there. I'm going to need the 1 and the 0 and then negative 5 and the negative 2. Okay, so then I bring down the 1 and I multiply and add, multiply, add, multiply, and I get a remainder of 0 when I add. Okay, so this is my next depressed polynomial. I started with x to the third. That's what I was dividing into, so now this will be x squared minus 2x minus 1. And it's a trinomial, so I could factor with guess and check. However, there aren't factors of 1 that'll get me to a negative 2 and add to a negative 1. So I have to do the quadratic formula now. Okay, so this is going to be my last step then. So far I know that 5 is one of my solutions. And now I know that x equals negative 2 is also one of my solutions. And now I'm going to do the quadratic formula with this so I can find my other solutions. Okay, so x equals opposite b plus or minus the square root of b squared minus 4 times a times c all divided by 2a. Remember this one here, that's my a, this is my b, this is my c term. Okay, so then I'll have 2 plus or minus the square root of, let's see, this is going to be 4 plus 4, so that'll be 8. So 2 plus or minus the square root of 8 all over 2. Now 8a can break down into the square root of 4 and the square root of 2. So that's really going to be 2 plus or minus the square root of 4 is 2. So I'll have 2 square root 2 all over 2. Whew, there's a lot of 2's. And I can reduce that, so I would have, see, the 2's out front will all reduce. It's not the one inside the radical. So I'll have 1 plus or minus the square root of 2. Okay, so that's my other solution. 1 plus or minus the square root of 2. So there are all 4 of my solutions. Now remember, I had a degree of 4 originally, so that should tell me I should get 4 solutions. Now, technically we were finding the rational zeros. Okay, so the rational zeros would be 5 and negative 2. When it says to find all the zeros, that means to go beyond just the rational numbers and find any, in this case, irrational solutions as well. Okay, so that's about as intense as the problems are going to get on your homework as far as doing this synthetic division. So this is a really good example of how you have a 2 or possibly 3-step process to find all of your solutions. Okay, last concept we're going to talk about is dealing with your graphing calculator. And here we have an example that says find all the real solutions of the following equation rounded to the nearest tenth. Okay, so that's kind of a clue that we need to use our calculators to do that. Now, before I just go to my graphing calculator and put this, and put this function in, I want to take a look at some of those concepts that we've been talking about in the previous sections about what degree we have. Is it even or odd? What does that mean? What's my lead coefficient? Okay, so my degree is 4, so I have an even degree. So that means the ends are going to be going the same direction on my graph. My lead coefficient is a 3, so I have a positive lead coefficient. So that means that both of the ends of the graph are going to be going up. Okay, so my degree is a 4. So 4 minus 1 is 3, so that means I'm going to have 3 extrema. Okay, I could have less than that, but I won't have more than that. So at the most, I could have 2 minimums and a maximum, or 2 maximums and a minimum. But if I was trying to graph this, let me draw it up here. Both ends have to be going up, and I have to have 3 extremas. That means I have to have 3 little bumps. So I'd have to start up, and I'd have 1 bump, and then another bump, and then another bump. So the graph might look something like that. Okay? That's if I have 3 extrema. Now it could look different if I had 2 or just 1 maximum or minimum. Okay? But what I need to do now is I need to go to my graphing calculator. So I'm going to pull that up and go to y equals and type in your equation and then hit graph. Okay, now we can't see everything that's going on, but that's okay because we don't really need to see the entire graph to figure out where our solutions are. Okay, we're trying to find the solutions, we're trying to find the zeros. So I don't have to worry so much about the actual shape to get the maximums and the minimums, but I do need to see where it crosses the x-axis. Okay. And I could zoom just a little bit. If I adjusted my window, I could get rid of some of those negative x values. And I could get rid of some of my positive x values too. Let's go down to like 8, let's say. So that'll help me zoom in a little bit so I can see where those parts of my graph cross the x-axis. And it looks like it's crossing between 0 and -1, and then between 3 and 4. Okay. Okay. I went back in and double checked my equation, and I had forgotten to type in the minus in front of the 2. So now, when I have my function graphed, slightly different than what you saw before on the previous slides, but now you can see that it does go a little bit closer to that shape that we had kind of estimated when we were graphing. Okay, so now that I have it zoomed in from like -5 to +5, you can see that the x-intercept looks like it's going to be between -2 and -3 and between 1 and 2, which is different than the incorrect graph that I had up there just a moment ago. So this is the correct one now. Okay? Now, your calculator will find the actual zeros for you. You could trace on the calculator if you wanted to, but that might not get you the exact value. So if you do second calc, and then you do number 2, which is your 0, and you do have to put the cursor to the left and then to the right, whoa, of where you think that 0 is going to be. Okay, so right about there, that's to the left of where I think that first 0 is going to be. So then I hit enter, and then I can arrow over to the right, to the other side of it, and hit enter, and then hit enter one more time. And then at the bottom of the screen, the graphing calculator will show you the -2.3. So that's going to be one of my solutions. And then if I go back to the graphing calculator, I can repeat that process at the other intercept. So if I do second calc, if I do 0, I have to arrow over to the right, but I want to stay on the left-bound side of where that intercept is. So I want to stay below it, or what looks like below it on the calculator. So I'll hit enter, and then I'm going to arrow over to the right so that I'm above it, or to the right of where that x-intercept is, and hit enter again, and hit enter one more time. And again, at the bottom of the screen, the calculator will tell you it's at 1.3. And notice that the y-intercept is going to be, or the y value is going to be 0. Okay, so that's what you have to be on the x-axis. You have to have a y value of 0, so that makes sense. So 1.3 is going to be my other value. So -2.3 and then 1.3 are my two solutions to that big polynomial. Okay, and there's the nice book graph. Okay. And again, they zoomed in from -3 to 2, and then from 20 to -20. Okay, so just make sure that when you adjust your window, you zoom in so that you can see the relative maximums and the relative minimums. Okay, you don't have to see all of them, but you can see there's a minimum and then a maximum and then a minimum, just like we had guessed. And then really, you just need to see where it's going to cross that x-axis. So if you want to zoom so that you can see the whole graph, you can, or if you just want to focus on where the parabola is crossing, or the graph is crossing the x-axis, that's fine too. Okay, so there's your homework for tonight. It's kind of choppy, so make sure you write those numbers down. And remember, I have the solutions worked out in the binder in the classroom. And if you have any questions, come on in and see me before school.